2 reads, a box slides down a 30-degree incline with an initial speed of 8 meters per second. Question A, what is the acceleration of the box? And B, calculate the final speed of the box after it travels 200 meters down the incline. And C, how long will it take for the box to travel 200 meters? How long will it take for the box to travel 200 meters? So this is also another very simple, interesting question. Question 2. Question 2. So the data we've been given at question 2 is that we have our angle theta of the incline, which is 30 degrees. We've been given the initial velocity, which is u of the box, which is 8.0 meters per second. We've been given distance traveled, 200 meters. And as usual, gravity is going to be equal to 9.8 meters per second or 9.81 meters per second. Okay, so question A is saying we should calculate the acceleration of the box. So the first thing we're supposed to remember is that this is what we have. If the box is there, and they've told us to say this incline, or they haven't mentioned anything about friction in this particular question, which means we're going to assume that the fall was through a frictionless incline. So I'll say the forces that are acting on this block, we have gravity causing weight, mg there, the theta is 30 degrees, same 30 degrees is here. We have the vertical component of our weight, cos theta. We have the horizontal component, is mg cos theta, just like this. These are the only forces. They haven't talked about any external force that is being applied on the incline. That means these are the only forces that we're having. So question A is saying we should calculate the acceleration of the box. So as usual, we're going to use Newton's second law of motion. This is A. We are going to say summation of forces in the x-axis should be equal to mass multiplied by acceleration. What forces do we have in the x-axis? We have the horizontal component of the weight, and this horizontal component of the weight is the one which is acting in the direction of acceleration. So I'm going to say mg, this is sine, sorry, this is sine theta, mg sine theta will be equal to mass multiplied by acceleration. So we're looking for acceleration. That means our mg sine 30 degrees over the mass will be equal to your acceleration. Mass and mass can cancel out. That means the acceleration of the box is equal to g sine 30 degrees. We can just plug this in. Gravity is 9.81 sine 30 degrees, and this is going to give us an acceleration, which is equal to 4.9 meters per second. 4.9 meters per second, so, or per second squared. So this is the value of acceleration that the box is going to slide with. That is the acceleration on this particular incline. Question B is saying calculate the final speed of the box after it travels the 200 meters down the incline. Calculate the final speed of the box after it travels 200 meters down the incline. So we've calculated the acceleration. So we can use this formula. V squared is equal to u squared plus c to s, where v is the final velocity, u is the initial velocity, 2 is the constant, a is acceleration, and the s is the displacement. So we are looking for final velocity. That means our v will be equal to the square root of u squared plus c to s. Our v will be equal to the square root of u is 8, so we have our 8 squared plus 2, 4.9, 200, like that. Our v will be equal to the summation of whatever is under the brackets. This is going to give us 2024 meters squared second squared, like this. Plug this into a calculator, you're going to get the final velocity as 44.988 meters per second. and that is the final velocity, ladies and gentlemen, on question B. This is the final velocity on question B. Question A, we've calculated acceleration as 4.9 meters per second. Then for B, we've calculated the final velocity as 44.9889 meters per second. Let's go to the last question, question C. We'll start it from here, which says, how long will it take for the box to travel the 200 meters? How long will it take for the box to travel the 200 meters? So as usual, we're going to use the formula for displacement, where we say displacement S is going to be equal to initial velocity, or ut plus half at squared. Okay, so our displacement, which is 200, we can just plug in now. Our displacement, which is 200, will be equal to 8 multiplied by time plus half 4.9 t squared. This is going to give us 200 being equal to 8t plus 2.45 t squared. Okay, so we can take the 200 to the other side of the equation, and it's going to become a negative, and I'm going to have 2.45 t squared plus 8t minus 200 equal to 0. Okay, so now we have this quadratic equation. So what are we going to do now? We are going to use the quadratic formula to calculate for t. We're going to use the quadratic formula to calculate t. And what does the quadratic formula state? Negative b. We're going to say t will be equal to negative b plus or minus the square root of b squared minus 4ac, and everything from here over 2a. So this is the quadratic formula, and we can now just start to plug in. We have our a as 2.45. We have our b as 8, and we have our c as negative 200 there. So let's now plug in these guys into this particular quadratic formula. So I'll say my t will be equal to negative b is 8, so negative 8 plus or minus 8 squared minus 4. A is 2.45 and C is minus 200. And all of this over 2 multiplied by 2.45. Our T will be equal to, simplify this equation further, we're going to have negative 8 plus or minus 64 plus 1960. And this over 4.9. Our T will be equal to negative 8 plus or minus. If we plug in the sum of 64 and 1960 under a square root, okay, so that gives us 2024. That gives us 2024. So we have 2024 under 4.9. Okay, so T will be equal to negative 8 plus or minus 44.9889 over 4.9. Okay, so the question is quite long. Just need to be patient and make sure you don't make any mistakes. So when it reaches this point, ladies and gentlemen, one thing we have to understand is that time should always be positive. T should be positive. So we're going to plug in both of the possible answers that we're going to get for T. Then we're going to get it, or we're going to pick the positive T as the correct answer, because T should always be positive. So we're going to use the positive root in this case, because it's the one that is going to give us a positive answer. So we're going to say, sorry. So we're going to say T will be equal to negative 8.0, or where am I getting the point? We can just say negative 8 plus 44.9889 over 4.9. This is going to give us approximately 36.5 4.9889 over 4.9. And this is going to give us time, which is equal to 7.5487 seconds. So this is the time taken for the box to cover the 200 meters on the incline with the acceleration of 4.9 meters per second squared. This is the time it takes. If you don't want to use this route, there is also an alternative route where I can just say um, time will be equal to, so this is an alternative route. Let me put a line there. Time is equal to, so in an alternative route, we can just say time is equal to V final minus V initial over acceleration. And this is going to be equal to the V final, we find it to be 44.9885 minus the initial velocity, which is equal to 8 over the acceleration, which was 4.9. And this is going to give you time of 7.5487 seconds. So using the alternative route, we are still getting the same value of time, but the method B is proving to be way shorter than the first method we used. So it is up to you to pick whichever one you'd love to use. This was question B, or this was question C, for finding how long it's going to take for the box to slide from the top of the incline with an initial velocity of 8 meters per second to the bottom of the incline. That is the time taken. And that basically means we are done with question 2. Question 3 is saying a 10 kg crate begins sliding down a smooth incline at 35 degrees to the horizontal. A, show that the acceleration of the crate is equal to G sine 35, gravity sine 35, and they find its value. B, find the net force of the crate. Find the net force of the crate. And C, what is the vertical displacement of the crate relative to its starting point after traveling 150 meters down the incline. What is the displacement of the crate? What is the vertical displacement of the crate to its starting point after traveling 150 meters down the incline? Okay, so this is also a very, very simple question. This is also a simple question. So we're going to start with drawing a free body diagram. Okay, so this is what we have. We have a crate here. The crate has a mass of 10 kilograms. Then the theta is equal to 35 degrees. The distance along the crate covered, displacement along the crate, which means in the x-axis is 150 meters. Then we have gravity, which is equal to 9.8 meters per second squared. Okay, so there is gravity acting on this object, causing weight of mg. We have theta here, and this same theta is here. So we're going to resolve this guy as mg cos theta, since the vertical component is the one which is adjacent to the theta. Then the component which is opposite to the theta is going to carry a sign. So we're going to say this will be mg sine theta. Okay, like this. So we also have a normal force. We also have a normal force acting on this particular object. And these are the only forces that are acting on it, since they've said the incline is frictionless. So question A is saying we should show that the acceleration due to gravity is equal to A, or is equal to G sine theta. And you should calculate its value. So in order for us to calculate acceleration, we're going to look at the forces that are in the x-axis. And the forces that are in the x-axis, we only have one force, which is mg sine theta, and it is along the direction of acceleration. So which means we're going to say summation of forces in the x-axis is equal to mass multiplied by acceleration. And which force do we have? We have mg sine theta, which is acting in the actual direction of acceleration. So we're going to say mg sine theta will be equal to mass multiplied by acceleration. We are looking for acceleration, so we're going to say acceleration is equal to mg sine theta, of which the theta is 35 degrees, divided by mass itself, Mass will cancel out with mass there. That means my acceleration is equal to g sine 35 degrees. This is what they had asked, they asked us to show or to prove. Then from here, we can calculate the actual acceleration. So the actual value of acceleration will be equal to 9.8 sine 35 degrees. And this is going to give us a value of acceleration, which is equal to 5.619. 5.619 meters per second squared. That, ladies and gentlemen, is the value of acceleration on question A. And that means we're done with question A. We can move on to the next question, which is question B. Question B is saying we should calculate the net force on the crate. So, as usual, F net, which is the summation of forces, should be equal to mass multiplied by acceleration, like this, of which we know the mass of the crate and we know the acceleration of the crate. So which means our F net will be equal to mass of 10 kilograms multiplied by acceleration of 5.619. And this is going to give us a net force on the crate, which is equal to 56.19. 56.19 newtons. So the net force on the crate will be 56.19 newtons. Or if you don't want, you can use that ordinary method we used to calculate the acceleration in part B. This is question, this is question B. You can use the ordinary method that we used in question A, where we say summation of forces is equal to mass times acceleration. Which forces do we have? We only have one force in the x-axis, which is mg sine theta, and it is acting along the direction of acceleration, which means it is a positive force. It is the only force that is acting on this object. So we're going to say the net force in the x-axis is equal to this same guy, the mg sine theta. Mg sine theta. Then from there, you're going to get this same value of acceleration, because I'll just say summation of forces in the x should be equal to mass multiplied by acceleration, like that. Then which summation of forces do we have? Okay, so let's move on to the last question, or the last part of the question, which is part C. And part C is saying is saying what is the vertical displacement of the crate relative to its starting point? What's the vertical displacement of the crate relative to its starting point? So the vertical displacement can easily be calculated, because we know the hypotenuse here is 150 meters. The theta here is 35 degrees. What are we looking for? We're looking for this vertical distance. So what are we going to do? We can easily use SOHCAHTOA and say sine theta is equal to opposite over hypotenuse. We already know the theta, so we'll say sine 35 degrees should be equal to the opposite over the hypotenuse, which the hypotenuse is 150 meters. We'll multiply sine theta with the hypotenuse. So that means our opposite, or vertical displacement, will be equal to sine 35 multiplied by 150. And this is going to give us a vertical displacement, which is equal to 86.04. 86.04 meters. And just like that, we've solved all the questions in this tutorial sheet. So thank you very much, ladies and gentlemen, for watching this video once more. Remember to subscribe to the channel, like, share, and leave a comment. And also remember to register with us to help prepare for a test. And until next time, stay blessed.